let's work through some problems calculating exponential change. Fun stuff, exponential change. Now, when we talk about the change, we are either talking about growth, where it goes up, or decay, where it goes down, right? So whether or not our values are getting bigger or smaller, that's kind of how you know. And that should be exponential. Okay, so let's start and look through some examples here. A $22,000 car depreciates by 12% per year. Is this a case of exponential growth or decay? Well, if it depreciates, that means the price of the car goes down, and therefore this is decay. All right, so we have an exponential decay here. So what is the change factor? Now, to refresh on the change factor, we always start with 1. And if you think about this, when you multiply by 1, your value does not change, right? So 1 is kind of like the stable metric. Now, if it's growth, we add the percent change. If it's decay, we take our 1 that we start with, our stable, and we subtract the percent change. So if we're depreciating, right, so we are looking at exponential decay for this one, by 12%. Well, 12% as a decimal is 0.12. So to find my decay factor, the change factor, I take 1 minus 0.12, and I get 0.88. So if you have exponential decay, your change factor should always be less than 1. So now we can determine the model which estimates the value of the car T years after its purchase. Okay, so we have our ending amount, which we don't know because it's after a certain number of years. We always start with our initial value. We multiply by the change factor, and because this is exponential decay, we've got our 0.88, and the exponent is our number of years, and in this case, it's T. So this is our model. Ending amount equals initial amount times the change factor raised to the number of years. Now, how much will the car be worth in 4 years? This tells us that T equals 4. So A equals 22,000 times 0.88 raised to the 4th power. Now, depending on your calculator, you might be able to punch that all in at one time. If not, we start with order of operations with our 0.88 raised to the 4th power, and that'll give us like 0.59969. It goes on and on and on. And this comes down to an answer of $13,193.30. So after 4 years with a 12% depreciation rate, that is how much our car will be worth. Let's move on to number 2. Airline miles have a tendency to lose value over time as airline companies change or update policies. Alicia traveled often for business and had earned 500,000 frequent flyer miles prior to her retirement. She estimates that her miles lose around 26% of their value from year to year. Is this situation growth or decay? Well, they lose value, so this again is decay. Now, I do want to point out right now that we know this is exponential because our change is in percentages. So percent change lets us know that this is an exponential formula here. Okay, so it's exponential decay, and that means we're going to take our 1 and subtract 26% as a decimal, which is 0.26. So my change factor is 0.74. So now if I want to write my model for any given year, ending amount equals, how much did I start with? 500,000. My change factor goes in parentheses, 0.74, and we raise it to the number of years, which in this case is just T, because we don't know the number of years. So, the next portion. How many airline miles will remain 5 years after Alicia retires? This is assuming she hasn't used any of them, right? If she just forgets they exist and they just depreciate by 26%, how many are left? Well, we plug in 5 for T. So the ending amount equals 500,000 times 0.74 raised to the 5th power. And if we round to the nearest whole mile, we have 110,950. So hopefully Alicia remembers about her airline miles and she cashes those in for some free flights before she loses all of them. All right, let's do one more. Wade found a rare Masters of the Universe action figure set in a box of his childhood toys. He's been tracking the price of a similar set online to monitor the rising value of his own collection. Use the table of values to address the following. Is this situation one of growth or decay? Let's start there. As we look from year to year, what do you notice about the prices? They go up. They increase. So since our values increase, this is exponential growth. That means our change factor is going to be greater than 1. Now here we are given a table, so we're going to use consecutive values to find our change factor. So that means we would use 248.68 over the previous year, 227.67, or we could use 271.63 over 248.68. Either way, it does not matter. When you divide both of those, you will get a value of 1.09. So our change factor is 1.09. Makes sense that it's above 1 because this is exponential growth. Construct the exponential equation that would calculate the value of this set for any year after 2020. So 2020 is considered here our initial amount. So we need the 227.67. So the ending amount is 227.67. Change factor in the middle, raised to any year. We'll call that T. So there's our exponential equation. Now, with this being said, because 2020 is the initial year, that means in 2020, T equals 0, because that's the initial year. So 2021, T would be 1. Okay, that's how that works. If we were talking about 2030, T would be 10 because it's 10 years after 2020. That's how that idea works. Okay, and the last part here, use guess and check to determine the first year that the collection will be worth more than $450. Okay, so we're saying the ending amount. So 450 equals 227.67 times 1.09 to the T power. So guess and check means we're trying to figure out what value of T puts us over the 450 mark. Okay, so if I plug in T equals 5, because this is kind of how I roll. So I would do 227.67, 1.09 raised to the 5th power. And that gives me a value of 350.30. Well, that's too low. So that's not going to work. Okay, well, I don't want to double that. That'll be way too high. Let's go that T equals 7. Okay, so 227.67, 1.09 to the 7th power, and that gives me 416.19. Well, that's not enough. So if I try T equals 8, 227.67, 1.09 raised to the 8th, I get 453.65, and there's my winner chicken dinner. So after 8 years, so that would be 2028. In 2028, the action figure set will be worth more than $450, assuming it continues to grow at this same rate of change. And that is calculating exponential change with some exponential growth and decay.